All right, so here's our objective for today. So as I started grading these masteries, and these are in no specific order. Some of you guys have some grading done. Some of you guys have no grading done on these because I just only got partial way through the stack. I realized that we have some things that we should talk about because there's going to be a progressing to mastery, but with how this is falling, and this is one of those times that you guys are grading your own test. You're going to turn this back in with your grading and with however you feel, whether you would have gotten a progressing or a mastery based on your performance. So this is also telling me, because the last time we did this, you guys were about exactly how I would have graded it, not a little bit harder on yourselves. Which is good, because most people, especially like, I don't want to say perfectionists, but people that are striving for greatness, they're critical on themselves because that's how you get better. So we are going to go over this together, and hopefully, my goal with doing this is Chapter 7 about equivalent expressions is really, really, really important as we get into Chapter 8. So by going over this together and having you discover your mistakes, I'm hoping it will sink in more and be more impactful so that, as we move forward, you will perform very well. Is Julian not here today? Oh, hey Julian. Thanks for joining us.
I just accidentally brought my trumpet to my locker.
Oh, you could have brought it to math class. Yeah. We could play taps for some dead math tests or something. I can tell that you don't think this is funny. So Julian, you just totally missed my intro. Who can tell Julian what we're doing? Jeremiah, give it a shot.
We're grading the test and we're being perfectionists, that's what you said.
Not so. Last time we did this, some of you guys were perfectionists. Like you were really critical to yourself. Some of you guys gave yourselves like an NP, and you only had like 5 or 6 questions wrong. And I'm like, okay, that's progressing, yeah, but that's not like not progressing. Really means like you were asleep. Like you really didn't get this. So remember, mastery means I got this. I have very few mistakes, and they're minor mistakes. Even if you look and you're like, oh, I get that now. When you tried it, you didn't get it. So that's the difference between like big mistake, small mistake. Did you just forget a sign, or did you do that 5 times? If you did it 5 times, you don't know how to carry that sign correctly. So as we get on through here, you need a blank sheet of paper out so you can write on there if you've made mistakes. You want to write the correct answers on that separate sheet of paper. Here on out, and I'm going to announce this again when we come back in January. Here on out, the only corrections I will look at have to be on a separate sheet of paper. I've spent too long trying to figure out what was the original, what was the second time around, what did you erase. Stop erasing. Once you get a test back, do not erase anything. It's good to be able to see what I did the first time to compare to what did I do the second time. What do I know now that I screwed up the first time? So you need that separate sheet of paper out. Then when we come back in January, there will be a progressing to mastery, but I don't want to give it to you yet. Why might that be? Why might I want to wait till we come back in January? Andrew, what do you think?
You'd be like stressed if you put grades in, and if we're gonna forget stuff and we'll have to review when we get that.
Yeah, it's not really because of the like stress thing. Like you guys have a long time over break to do things, but I'm just not gonna put these in math yet. So chapter 7 won't show up in math until we come back.
Thank you very much.
But you're welcome. But because honestly, I want you guys to enjoy your break. Spend time with your family, enjoy time with friends, enjoy the holidays. When you come back to school in January, though, I want to check, do you still remember all this? So by doing, if you're and actually I might just have us all do it, even if you master this test, I'll probably have you do the progressing to mastery just as a review. So that will be like our kickstart back into getting, and we'll check over chapter 8 too. We'll hand those back when you come back in January to see, okay, what did I screw up? What do I need to remember? Then as we get to chapter 9, that will hopefully refresh our memory. So if we have any questions about like kind of how our plan is going to go, because tomorrow we don't have math class. Yeah.
So are we just trying to correct what we did wrong? And put
We're going to go over this all together.
Okay.
Yeah, we're going to talk as a, we're just going to have a discussion today about
So, but
this.
if we get something wrong on this,
Put it on the
down.
blank sheet. Yep.
Okay, but like.
And,
mine
like,
is only
circle it,
partly
mark
graded,
it.
So
Huh?
Mine is only partly graded.
I know. That's so as I grade like the left column of everybody. Then I grade the right column of every. So some people's are partially graded, but I made it about halfway through and I was like, I just want to go over this with everybody. And I just stopped grading.
Yeah.
because at that point, I'd rather have you guys grade yourselves. So the less I write on there, the better it is for your brain of like, oh, I should have done this. And so like, you have that realize moment.
Number 4.
Andrew?
This is kind of for overall. What's our goal at the end of the year? Like, what chapter are we trying to get through?
That doesn't even matter. Because I just tell Mr. Hall where we stopped, and that's where you start.
Oh.
So we're trying to make it as far as we can to answer your question. So in simplifying an expression, we're looking for like terms that can be combined together. What two things like terms must have in common? And I try to remind you by asking, could you combine x, y, and x squared all together? Monica, what do you think?
The same variable or the same constant?
So that's kind of the same thing. So when we say same variable, I haven't used the PDF on here yet, so we'll see if the ink works. It might want me to turn on Smart Ink. I'm still getting used to my new computer, guys. So the first thing that most all of us had was same variable. But then there was another thing that a lot of us didn't have. Elena?
Then they have like the same exponent.
They have to have the same exponent. So when you're looking through, and if this won't let me write in Smart Ink, I might have to pull up my browser.
Wait, if you got it right, can you write a check?
Did you have both same variable and same power or same exponent?
Yes.
If you did, just put a check mark next to it. I'm gonna pause. In the following expression,
Wait,
We-
how did you do the first one again? I forgot.
it's variable and power or exponent.
So if you only got like half of that right, is it still just wrong?
I mean, it's not right.
But it's not. So you should just put like.
So that's the thing about mastery. Like, did you show that you fully understand it? No. If you didn't have in there that they need to have the same exponent, then you did not show that you fully understand it. I really don't know how to make this work. Everything works except for PDFs, apparently. I guess I can do this.
You guys should make like another thing for the grading system. We should put like halfway symbol, like just a straight line.
That'd be a 1.
That would take away
So-
the mastery.
Let's see if this works. I'm getting really crafty here.
You gonna
Or you can do it like this.
So here, what we're talking about is number of terms, then what are the coefficients, what are the constants. So for my number of terms, I've got a 5x squared, an 8x, and a -7. Almost all of us knew that the number of terms was 3.
Aw, man.
Now, what a lot of us didn't realize was that the coefficient, who can define what coefficient actually means? Not tell me what they are in this problem, what it means. Jeremiah?
Isn't it the number next to the exponent?
Oh, close.
It's variable?
A little bit more details.
It's the constant next to a variable.
Careful,
Oh wait,
because
no, it's not a constant, but
it's a
whole
known
number.
value. It doesn't have to be whole, but it is a number. It's the multiplier to that variable. So here for your coefficients, the multiplier of x squared was only 5. You do not write the variable with it. The multiplier for the x was only 8, not 8x. The coefficient is only the number. If you wrote down the letters with it, you need to write on your paper only the number or only the multiplier. Andrew?
Let's mess this up for constants. Do you put the actual number that is the constant or the number of
You put the actual number that is the constant. So that's why here it said number of terms,
number?
and then what are the coefficients, what are the constants. So Ellie, what's our constant here?
It's 7, but I put -7 because it's a subtraction.
So what is your constant here?
-7.
-7, because the sign in front of the term goes with it. That value is a negative value. A lot of us had +7 there, so if you did, you need to correct that, put that on your separate sheet for your corrections. For number 3, Ooh, that moves really fast. Now, this, on multiple choice problems, here's the dangerous thing. You guys think that you like multiple choice problems because they're easy. They're not. You just have a finite number of options, but multiple choice often have trap doors. Who knows what the answer is here? Which one correctly shows the distributive property? Ashley, what do you think? A. So we have 25B plus, I forgot, this won't let me write. We have 25B plus 25C. The plus in the middle carries over and is still a plus in the middle. Now, in 4, though,
Question.
A in question 4 is a trap door. Because subtraction here, or a negative A value, addition here, positive A value, A is wrong. I saw a lot of people had marked A, you fell into the trap door. Anish, what's the right answer here? C, because, hey, if you got this wrong, I need you to show the work. So we have -2 times A minus 3. -2 times A becomes -2A. But -2 times -3 becomes a positive 6.
Wait, I'm confused. So
What? What about?
-2 times -2a. -2 times 3 is positive.
-2 times just A gives me a -2A. -2 times -3, because this value of 3 is technically negative. Negative times a negative makes a positive.
Wait, so 3
I
is
thought
A.
it was B.
4 is C. Question 3 had been A. Yes. Question 5. So rewrite the expression using the distributive property. Guys, this was supposed to help you on question 4. When you start solving this, and your brain is thinking, oh, wait, negatives. Guys, I write the tests intentionally to help you. This problem should have reminded you, oh, wait, go back and check, did I carry the right signs where they needed to go on the last problem? Because this, -7 times x minus y, becomes what? Tom?
Wouldn't it be -7x plus -7y?
Close.
Or -7x plus.
-7 times x makes -7x. But -7 times -y makes a positive 7y. So it's -7x plus 7y. Anish?
I didn't add the positive, I just put 2 negatives. Would that be okay?
No, because we need to simplify all the way down if possible. So your answer's not wrong, but it's not all the way done. So if I had gotten to your paper to grading, I probably would have written keep going. Or put a question mark next to it, like you can simplify further. We always want to put it in simplest form. So you can't have minus a negative, that's not proper. It's not wrong, but it's not proper. Jeremiah? Yeah. So we have the 2 times 3 minus x.
I got 6 minus 2x.
When 2 distributes to the 3, you get 6. When 2 distributes to the minus x, you get -2x. So we get 6 minus 2x for number 6.
You can do
I don't know why I keep screwing up names right now. Ellie?
Going back to 5, I put 7x minus -7y, but I simplified it down to 7x plus 7y.
So first off, your x value has to be negative.
Yeah.
And then, so yeah, the minus negative does simplify here, but if you miss this negative, then it's wrong.
Okay, I got that negative. I don't
Okay. Because you said 7x, you didn't say negative.
Sorry.
It's okay.
My brain.
You gotta make sure that you give the numbers their value, otherwise they get upset. The numbers get mad when you don't give them the right value. So on 7, we have -3. Again, be careful with your signs. X minus 4. I'm going to go ahead and turn this off, guys, since it's just like an ominous blue box. Because we're not really using it today. It's like the blue screen of death. So we distribute, again. Anyone going to help me, or do I need to start calling cards? Sean, help me out.
Oh,
My green sensor is weird. Negative 3x, and then when the negative 3 comes to the negative 4, that gives me a positive 12. That is not a decimal point, that is just a dot that somehow made its way there.
Yeah.
Make my way. Walk in fast. Please see the path.
Any questions so far? Up through 7.
I keep forgetting to like.
Now, starting at 8 is where order of operations really becomes important. So, 8, everybody, write this on your separate sheet, even if you think you got it right, because might as well. It's good practice.
It's good.
Oh, you got a question? Sorry, what is it, Jeremiah?
I said, would it be fine if I did negative 3x minus 12 because it's the same thing?
No, it's not. Your 12 becomes positive. It has to be plus positive 12, because your negative 3 times the negative 4 makes a positive value. It's not, what you said is not the same thing. Does that make sense? So, back here. Jeremiah with me. So, your distribution that has to happen here takes the negative 3 and multiplies by x. That gives us negative 3x. But then the negative 3 multiplies by the negative 4. That's how you get the positive 12. Because negative times a negative makes a positive. So, Sean, you were going to help me, right? Or did you help me in the last one? Elena, what would I do first here?
You would add together 12 and 2.
Now, if we follow down order of operations, can I solve inside my parentheses? No, I can't add these, right? So we move on down. Exponents. Are there any exponents? No. Then I get to multiply, divide. There is multiplication to be done. So this is where people screwed up. You cannot add these, although they look like they're like terms, because we don't know what this is yet. It's combined with all of this. First thing we have to do is the multiplication where we distribute. So that 12 doesn't do anything. Then 2 times m is 2m, and 2 times 9 is 18. Now I can look for like terms. Ozzy, what can I add together?
You not there 12 and 18.
The 12 and the 18 add together to give me 30, and the 2m, no one likes him, so he's alone.
I did 23 plus
Oh my gosh.
Any questions? Take a moment on your own. Look at your work for number 9 and see if you think you got it right.
Probably not. Oh, Siri.
Hey guys, I didn't say talk out loud and say random things that are unnecessary. I said look at number 9. That doesn't need your math. Whitney, what would be the first thing I need to do to start this solution process? Or actually, it's a simplification process. Sorry, we're not actually solving anything here. So, can I solve inside my parentheses? Think down the ladder of order of operations. Can I add or can I subtract these values or can I subtract these values? They're not like terms, so no. So, yeah, so there's no exponent, so I keep going down the ladder. So now I distribute. This distribution gives me 6x minus 2. This distribution gives me a negative 3x plus 12. You can either, I couldn't have paid you to ask that question at a better time. You can either assume you are adding values together or use that negative 3x as a minus 3x, because plus a negative is just minus, so we don't need that x there, or sorry, we don't need that plus there. It can just be 6x minus 2 minus 3x plus 12. Now, if this 3, now we're not done, but if this 3x did not have a negative, then we'd have to put a plus sign between there. But it's got a negative, so I can look at it as if it was subtraction.
So we just did that.
You're not done. It says simplify. This is not simplify. You took a step. So now, I'm trying to see my, there we go. I combine like terms. What is a like term to 6x, Monos?
-3.
-3x. When you're combining those like terms, signs is what trip most people up. So 6x minus 3x gives you
3x
3x
plus you do -2 and is like terms with 12, so you get 10.
-2 and 12 gives me a positive
Yes!
10.
Wait a minute.
It's like you just won a
Wait a
car.
minute. Wait a minute.
You
I
got
wrote,
it.
I wrote 6x minus 2.
Hey guys, what's up? Andrew raised his hand and is asking a question. You're rudely talking over him.
I did 6x minus 2 minus 3x plus, or no, minus 12, and I still got,
It's not minus 12. So you made two mistakes.
and I still got the right answer.
So you made two mistakes. This, if you thought it was minus 12, and you had this as a -2, right?
Oh, I see what I did.
Did you have this as a positive accidentally?
No. No, it's the same. Everything's the same. I changed this because I knew I still got it right, but
I can't tell whether you're using a positive or a negative there. You don't even work, Sean. You know we're on 9, right? So this. So you were looking down here for a moment. This positive 12 should not be positive. Or, no, you're good. Or did you just change that?
No, no, it's fine. It's just
Here's your only issue. That 10 needs to be positive. Because your positive has a greater power than your negative, it is stronger,
I see
right?
what I did though.
Yeah, 12 is stronger than 2. So positive wins out. I really need to get my software settings back to what I was used to. And 10, right? Check out 10 for a moment. Just like we just did on the last one, think, did you do that process correctly? So we have 10M. Gentlemen, if you can't handle yourselves, move. I've made it this far through the year without making a seating chart. I really don't want to right now. Like, that's another one of those things where I'm like rogue. Like, you're supposed to have a seating chart. You're supposed to assign seats. I really don't like doing that because I want you guys to sit wherever you feel most comfortable. But if you can't handle yourself, move. So 10M plus 2 times, is it M plus N?
Yeah.
I've already missed like 5.
Mr. Hone, what's the first thing I do here?
You would multiply 2 times m, and you get 2m, and then you multiply 2 times n, and you get 2m plus 2m in parentheses.
Did anything happen to my 10M?
No.
So I just carry it
not
down.
yet.
And do I still actually need parentheses around these guys?
No.
No. So now, Dom, what do I do?
You can simplify the 10m plus the 2n, which can get you 12m plus 2n. It's annoying that they said 12m and 2n.
Welcome to the world. Not everything works out nice and easy.
Like m and n.
Wait until you have to use O as a variable.
Wait, you use O as a variable?
You don't want to, but there will likely be a situation, or T,
Why does it matter? Why would you ever use that as a
Because it looks like a
because
zero.
it looks like a 0.
Oh.
So if you do that, I highly advise like making it look, I don't know, unique or something somehow. Or just change it.
Why would you ever use that as a variable?
Or just change it. Or T. I mean, we use time a lot, but I like to change that either capital or something else. Now, in 11 and 12, we're being asked to factor. Who can remind me of the process of factoring? Anish?
It's basically expanding it, so it's like unsimplifying it.
Yeah, so factoring is like unsimplifying it. So we have -2x minus 14, and what we're really thinking about is there a value that I could divide both of these by, which would then come out front, we're essentially undistributing. So Andrew, is there a common value I can divide both of those by?
-7.
Close.
-2.
Yeah, your brain's ahead of you.
Yeah.
So if we divide by -2, that -2 comes out front. Guys, please write this down. A lot of us were struggling with this. -2x. Now, if you thought the greatest common factor was just 2, you're close. But here's the thing about greatest common factor. We want to factor out as much information as possible. So -2 provides more information than just saying 2. So -2 is technically our greatest common factor, which leaves us on the inside with just x plus 7. Because the doesn't work if we all talk at the same time. The -2, when it comes and multiplies by +7, will get the -14. So check your signs. You have a negative out front for your coefficient, and addition between the x and the 7.
So is that correct?
This is the end.
Oh, okay.
That's it.
I thought you were gonna say like take away the negative somehow, and I'm like,
I don't know how you would.
yeah.
Now, here's how we know we did this right. Both of these values are now positive. Now, if they don't both start with the same sign, we can choose. Whether you factor out a positive or a negative, that's up to you. But if they both start negative, factor out that negative. Get rid of it. So in 12, we have 8 minus 4x. What would be the greatest value that we could divide them both by? Dom? 4. You could do a -4 if you really felt like being feisty, but yeah, you don't have to. Here's why. Now, don't write this yet. 8 divided by -4 would then, in my parentheses, give me a -2, which, not super great. If I just divide as my greatest common factor being 4, then I get my 4 out front, and I get 2. What comes after that? Minus x. To keep that minus or that negative preserved. Yeah, but it's unnecessary. You can, but it's unnecessary.
Yeah. Would it be wrong if I did 2 in parentheses and then 4 minus 2x?
Yes, because you did not factor the greatest common factor. You did factor it, but you did not factor the greatest. Lane?
How did you get 4 on the outside if you did 8 divided by 4?
Because it's what you divided by.
Oh.
So what you divided by goes up front, and what... Guys, stop talking. It's really rude. I can't even focus to explain a question from your peer. If you have a question, your peers probably do too, and they would benefit from your information or your question. The reason the 4 comes up front is that's what we divide by. What goes inside is what's left over. So when I do 8 divided by 4, I get 2. When I do -4 divided by 4, -4x divided by 4, I get the negative or the minus x.
Okay.
So what goes inside is what's left over. Questions? Moving on. We have the 20 plus 5 times 2 plus z. If you, I'm going to start to move a little quicker because we're running out of time. If you factor that, if you distribute that, you get 20 plus 10 plus 5z. 5 times the 2 gives me 10, 5 times the z gives me 5z. I combine my like terms, and your right answer there is 30 plus 5z. That one was all positive. Hopefully that one was a little bit easier. Now 14 switches back to a little bit harder. We have 2z plus 4 times 5 minus z. We're doing 14 now. I've already explained it, so I'm not repeating myself. There's no time to repeat myself, Jeremiah. You need to be here on time, and you need to have your ears open. If you don't do those things, I can't help you. When we distribute, we get 2z plus 20 minus 4z. This is where it gets dangerous. What's your final answer?
20.
No.
Negative 2z.
Negative 2z. Because if I have a positive 2z and a negative 4, the negative is stronger. I hate this software. You're joking.
No.
So negative 2z plus 20. Now you could do your 20 first, but I want you guys to get used to the variables should come first, and the higher the power is, the further to the left it gets. So if we had like an x squared, this would be x squared minus 2z plus 20. The higher powers go first, but we don't, so please don't write that down. That is not accurate for this problem. Julian, question?
I don't know if I could do this, but I did 20 minus 2z.
Yeah, that's fine.
Okay.
But so when we get to looking at standard form equations, you would put your variable term first. So yours is fine. You would just switch them around if you wanted to make the line.
Why would they use these?
If I go to the store and I tell you that I buy this can for $1.25, this can for $1.25, this can for $1.25, this can for $1.25, and that can for $1.25, how can I find out the total price I'm going to pay? Allie?
Multiply each of those, or multiply how many cans of soup you have by 125.
Now, I didn't tell you what my cans were, but I told you how much they cost, so I agree. Multiply how many you have by the cost. But now I tell you, these are chili. And these are soup. Does that make a difference? No, that doesn't change my price. And that doesn't change my solution process. So, up here, this is trying to get you to understand when things cost the same, they are the same, essentially. We can put them together. So, to talk about my cost, I'd end up paying $1.25 times whatever my total chili and soup
That
was.
was on our home.
I know. It was important. That's why it's on both. Likewise, drugstore. Sorry. What? It's this 1.25 times C plus S. Same type of problem, but now we actually start with like terms. Here's what, if you're struggling with this, you need to recognize. What number's in front of this C? 1. A 1, right? So this is 1C minus 4,500C. Or if you look at the problem, it's 100%, then they lose 45%. If you had everybody, you had 100%, and you lost 45%, what do you have left? 55%, which we write as 0.55 C.
Mr. Hudson.
Hold on, Jeremiah, what do you mean? I hear your howl back there.
No, I'm saying I have like 10 problems wrong.
I have a couple hypotheses. Julian?
This is kind of a random question, but do you ski or snowboard?
I used to snowboard when I was a kid,
Yeah.
and last time I went to an actual slope, and I tried to snowboard, I realized I don't like my feet being fixed anymore, so I got snow blades, because I used to skate, like inline skate, and I'm pretty good on snow blades.
What do you mean?
I have- Like on a snowboard, you can't independently move your feet. On snow blades, so like the short skis that are a little bit fatter, I can do whatever I want. I can I used to inline skate, so like like Mad River, you know their terrain park.
Yeah.
We went over there on the snow ski or the snow blade things. That was fun. You guys don't realize that adults can have as much, if not more, fun than you guys can have. Same type of problem as 16, except now
Adding.
they're increasing. We're seeing a 20% gain. So if we had 100% and we gained 20%, what do we end up with? 120%, or 1.20 times P, whatever that P will represent.
That one I actually got right. I got it right. Mr. Hudson, I know
Sir.
I got number 16 wrong. I didn't see that. Like, I thought I did number 17 first with you, and I saw that it had a plus sign, and then I went to number 16 after that, and I thought that one also had a plus sign, so I added the 2 instead of subtracting.
It was 1.20p because it's really 120% of p. So we represent 120% of p by 1.20. Ellie?
Can I help you with 18?
Yeah. Hey, chill. We only got like 4 minutes left. Ellie, what about 18?
Okay, so 18. 18, you have the two
Guys.
same constants. That's what
Coefficients.
I can words today. I'm sorry.
It's okay. Coefficients. 2.50.
Coefficients. And so basically, you factor out the greatest common factor, which would be 2.50, and you just do the little p plus b in parentheses.
So my 2.50 is the greatest common factor because I could divide on both sides by that. Then what I have left over is just p plus just b. I cannot erase like I used to. Come on, Hudson. Because if your packages of plates and your packages of bowls cost the same amount, I'm just going to have $2.50 times however many packages I bought. So honestly, I could rewrite an equation, and I could say this is really 2.50 times t, where t equals p plus b. It's my total. And then I could simplify it out like this. This is a substitution method that we will use more as you get into Math 8. And 19, I believe this is our last one, right?
Yep.
So this is always an interesting problem to think about. You have two girls, Bella and Ashley, are currently like dumping water into a tank. But at the same time, the tank is leaking. So every minute, each girl can have 11 gallons. Imagine those like really big buckets or whatever. But every minute, 23 gallons leaks out of the hole. Honestly? Yeah, which one do you think?
I think it's B because both girls are adding 11 at the same time, so 11 plus 11A, and then take away 23 because that's how much you're losing.
Yeah, 19 is B. Now, we could have put the 11B plus 11A in parentheses, but it wouldn't matter because they're not like terms.
Do we say
So,
turn it?
you want to, hold on. Hey guys, I still have 3 minutes, like, technically I still have at least 2.5. You want to staple these together, and on the top of it, give yourself whatever grade you think that would deserve.
The test or
The test. What you had done originally, the work that you showed, this is what I know when we did that test.
What about this part?